Have you heard? I think you have already encountered the word enzyme, no, in your previous courses, no. So, any idea what enzyme is all about, or what would be the purpose, use, or where can you find enzymes? Anyone? Asa mo ang tag-enzymes? For example na, if you can remember sa balay, di ba sa una magluto inyong mga ati, kuya, lulululan, no? For example, maglata o kuan, maglata o baka, ginabutangan nila o papaya, di ba? Kaya dali na daw siya malata kung butangan daan ng mga ilan. Okay, so one consideration, for example, other reactions. Daghan, no? Daghan mga gamit where you can find actually enzymes. So one consideration kato kung di nga magluto mo, and one possibility nga dali na day maluto siguro inyong gidungag or gilata ng mga karne is there is a possibility that there are enzymes that can be extracted sa mga papaya, no? That could facilitate para mahimong mas matender dali ang atong mga giluto. So those are one of the functions of an enzyme. So long before their chemical nature was understood, natin mga gitawag na yeast enzymes, no? Asa nato na nakita kanang maghimo og bread. For example, bantayan ninyo para mo alsa, di ba, ang bread. If you are into baking, no? Ginabutangan sa mga bakers og yeast para patubo, no? It's actually a yeast enzyme. Kung mag-prepare mo og naka-prepare o alcohol or wine, pag mag-prepare po ta og wine to produce alcohol gikan sa sugar, no, ginabutangan po nato yeast. It's actually also an enzyme para dali ra ang reaction to produce an alcohol, because normally kung mag-prepare lang for example og wine, it takes very long time. Okay, so mo na ginabutangan og yeast, so it acts as an enzyme. So the action of yeast and sugars, unsa man na siya. For example, kana mag-an mo bread na produce carbon dioxide gas that cause bread to rise, di ba? Abantayan ninyo pagbutangan ng yeast, motubo siya after some time. And then kung mag-prepare pud mo og wine, wala ninyo na nahimo sa lab or sa organic, no, chemistry, should be organic chemistry. But kung mag-prepare mo og wine, usually do that by adding some yeast also, and for that we are able to ferment sugars in fruit juices, for example, like depende sa yung fruit juice. Usually we have the grapes, right? Or sa Philippines, you can use other fruits food if you like, you know? And then you can convert that easily into beverages, alcoholic beverages. Also, it was thought that enzymes or proteins until 1980s were enzymes made up to RNA. It catalyzed cellular reactions involving nucleic acid. So it was discovered a long time ago. And enzymes undergo actually all reactions of proteins, including denaturation. So we will discover later, what is the nature of an enzyme. So a person, for example, suffering from a very high fever runs the risk of denaturing certain enzymes. Kainit na kaayo, no? And when enzymes undergo reactions of proteins that would include denaturation, it's possible nga kung kita hilantan, no, we run the risk of denaturing certain enzymes in our body, no? So enzyme activity is usually regulated by other substances present in the cell in which they are found. And it can be actually activated and deactivated anytime. So look at general characteristic of the enzyme. So considering enzyme is an organic compound that acts as a catalyst for biochemical reactions. So it acts as a catalyst. If you were into general chemistry, you pass through general chemistry, diba? And you've learned that catalyst is, unsa nang purpose sa catalyst kani in chemistry? Jane? Unsa nang catalyst niagi mo chemistry sa high school o kuan general chemistry unsa purpose ng catalyst. Catalyst is a substance that unsay purpose. For example, kung maglata mo og baka nga modaga baka sa may dugay lata maglata mo og baka mo dagan siya og 5 ka oras ug butangan ninyo kapayas mahimo na lang siyang 1 ka oras. Unsay purpose sa catalyst? Catalyst is a substance that anyone
Increases the reaction, ma'am.
yes increases the rate of reactions. It hastens. So since it increases the rate of the reactions, ang usual nga reaction nga dugay, for example, dugay, mahimo na lang siyang dali. In fact, it's one of the research, no, discoveries that the scientists would want to do, no, that for example the biochemical the degradation rather of kanang mga plastics, no, the usual plastics posible siya but it takes very long time kanang mga kuan. So normally kung kita nagpuyo ta siya sa earth posible siguro siya nga ma-degrade but it will take very long time. May mga plastics nga dugay kaayo. So muna ilang ginapangita, is there a particular enzyme or for example bacteria that would act that would have proteins that would act as an enzyme, no, to fasten the degradation of, for example, kanang mga pesticides or kanang mga hazardous na mga chemicals or materials that is kanang excreted dito sa environment nato sa mga soils. So a catalyst is a substance that hastens chemical reactions or increase the rates of chemical reactions. For a reaction, for instance, it would normally take, for example, 1,000 years. For example, kung magpa-degrade og kanang plastic, normally, so possibly ma-degrade, but it would take 1,000 years. If there is an enzyme that would possibly degrade, for example, a plastic for only like 10 years or 5 years or 1 year, no? So it would be a good one. So that is one of the kanang research actually that scientists are actually doing right now, no? So enzyme comes from the Greek word en or in, enzyme, from the word yeast. And most proteins actually are made up of the nucleic acid, the ribonucleic acid. No? It increases the reaction rates from 10 to the 9 or 10 to the 20 times. Imagine, unsa nang 10 to the 9, di ba a billion is just 10 to the 6? 10 to the 9 is a billion. No, imagine if the reaction would increase to 10 to the 20 times. So it's very specific also and very reusable and well regulated. So that is the main functions of the enzyme. Increases the rates of reaction by 10 to the 9 or 10 to the 20 times. So the increase niya by a billion times, millions a billion times. So the enzyme structure has 2 general structural classes actually. We have simple enzymes. It's composed only of protein. So of course we have been into protein na in chapter 5 in the previous chapter, di ba, we've discussed about proteins and we've learned that proteins are made up of amino acids. So simple enzymes are simply composed of proteins. And in fact, one of the functions of proteins that we have learned in the previous chapter is that it can act as an enzyme or catalyze reactions in our body. Now, there are too many reactions in biological systems. Okay, for example, digestion of food. No, normally kung walay enzyme kanang kaunta, sindugay pa siguro kay ta mahilisan, no? And there are enzymes actually that would help us digest our foods. Okay, so nagingon nga simple enzymes, proteins lang siya, amino acid lang siya ang component niya in the structure. But there is also what we call as conjugated enzymes. The conjugated enzymes has a non-protein part, and a non-protein part is also called a cofactor in addition to the protein part. Ang protein part, tawagon natin na siya apoenzyme. No? So in other words, ang conjugated enzyme na siya protein part ug na siya non-protein part. So na say protein part na siya amino acid chains, certain number of amino acids. Remember your like a lecture laboratory, no, when you look at on the structure of a protein, no, na siya chains of amino acids, and din na sa number of amino acids being present. Another is that non-protein part. You can call that one as conjugated enzyme. There's also what we call as cofactors, and those cofactors can be a small organic molecule or coenzyme. Tawagan na siya coenzyme. Na siya molecule na part, which means dili siya amino acid. Or kung dili man siya small molecule, there is an inorganic ion. So it's either a small molecule or an inorganic ion. Example, zinc ion, let's say cobalt, what else, or chromium, no? So it's possible. So here is an illustration of what is you have an alpha enzyme. Okay, we have the protein portion you have here, and you have the cofactor here, like a non-protein part in addition to your protein part, and that will include the whole enzyme. So we call this one as a conjugated enzyme, and then this one is, it can detect, for example, a particular substrate. So the nomenclature and classification of enzymes is based on the type of reaction catalyzed and the identity of the substrate. So it's a substrate. The substrate is simply the reactant in an enzyme catalyzed reaction, or the substance upon which the enzyme acts. Kanang unsa siya nga substance ang catalyze sa imong enzyme nga ma-transform into a product. Now, for example, later we'll have an example. So here is an illustration of our active enzyme, and here is an illustration of our substrate. So our substrate can be any molecule, no? It can be any compound that will be also called a reactant. So it's a reactant that can be transformed into a product, and the enzyme is simply a substance that would help the substrate, or also called the reactant, that can be easily converted sa desired product. So there are again 6 major classification of enzymes. One is the oxidoreductases. Again, when we name our enzymes, it will be based on the kind of reactions that they would undergo. So the oxidoreductases catalyze redox reactions. So it's a redox reaction. Remember your general chemistry 2 or 1, there is an oxidation and reduction occurs. So when there is reduction, there is also oxidation. They are always hand in hand, no? Because when there is oxidation, loss of electrons, another substance will have to accept the electron. So pareha na siya mag-uban na siya. So for example, here we have a lactate. You have COO minus. Again, when you have the structure, it means it's a carboxylate. It's a C double bond O, and then CO. Okay, daily is the oxygen bonded to oxygen. It's a carboxylate. Carboxylate minus the hydrogen is carboxylate. And you have this is the structure of a lactate. And then you have, for example, an NAD plus. Wala gipakita, no? We'll show you later on the structure of NAD. Okay, let's say it's positively charged, no? And then there is this one, you see here, this an alcohol here. And when it reacts, when this two reacts, no, what happens is this one is being oxidized to C double bond O. No, C double bond O is of a much higher oxidation state than COH. Okay, so carbon here would have a more here will have a higher oxidation state than this one. This one is the oxidized product, and this one is the reduced product. And in the process, the hydrogen will be given to an ADH. So this one is the one that accepts, no, the electron comes from here. You will have an ADH plus you have the hydrogen here. Okay, you have 2 hydrogens that's being removed, and you have here the reduced coenzyme. So this kind of reaction, you can see whenever you see a reaction that involves an oxygen and one is OH, one is C double bond O, or a higher one, it's taken find zero bond OOH, the carboxylic acid, or zero bond O or zero bond OH, no, it's always an oxidation process, and you could expect that the other substance will be reduced. So if this one is oxidized, then you could expect that the other one, let's say Na plus, is reduced to this one accepting electrons. Here you will have your NADH here. Okay, so this kind of enzyme again is called oxidoreductase. Oxidoreductases. Okay, so there's an oxidation, reduction, and you will notice that enzymes will end with ASE, ACE. Another is transferases. So transferase. S na siya S kay many man. So this one catalyzes the transfer of a functional group from one molecule to another. So from the word transferase, it means to transfer a functional group from one molecule to another. So the name itself, you would have an idea of what the enzyme would do or what would be its function. So for example, here, you have your glucose here. Okay, this is the structure of your glucose, down, down. This is an alpha, down, up, down. Again, you have your glucose H2OH and O in a cyclic form. And then you have your ATP. The ATP is hydrogen triphosphate. This one contains the phosphate group. No? So what happens here is that the phosphate is being transferred here. But to this compound, you will notice here that for the OH, you can see there is a phosphate group here. Okay, so for the phosphate to be transferred here, it needs an enzyme. Otherwise, dugay kaayo ang reaction. And because of that, you call this classification as a transferase. And this one, since it's a 6-membered ring, that's the substrate, you call this one as hexokinase. And this is the other one. You have the lactate dehydrogenase. We call this one, this is a particular specific name for this enzyme. Call this one a lactate dehydrogenase because the hydrogen is being removed. Dehydrogenase, ACE, you'll still end with ACE. This one, we call this one as a kinase. Now there is a transfer of functional groups, and it's a 6-membered ring. So generally you call the enzyme as a hexokinase. But the general classification is you have this transferase. The other one is oxidoreductase. And then the third one, it catalyzes the hydrolysis reaction. Let's say hydrolysis reaction, we always involves water. Now we add water in the reaction. So in which addition of water molecule to a bond cause the bond to break. So pag mag-involve na of water, you call that one as hydrolysis. So for instance here, you can classify this one, this maltase, ganong maltase ni siya because this one involves a maltose. Okay, down, up, down, down, up, down. So maltose is 2 glucose unit. Now the other, this one is a beta alpha, and this one is an alpha. Remember your carbohydrates. Okay, so in the presence of with water, this one, this this glycosidic bond is being broken when water is being added here to get back your 2 glucose units here. Okay, so na-add si HOH, diba? 1 OH, 1 OH, H is here, the OH is added here. Sorry, the OH is added here and the hydrogen is added to this molecule here. Either way, it's the same. Okay, and this one you will have, this one is you have a maltase. Maltase because our substrate is a maltose. Anyway, we're not yet very particular, but you can have an idea based for a specific enzyme kung unsa ang iyahang substrate. For instance, here maltase lang, the substrate must have been maltose, for a hydrolysis kind of reaction. And this one undergoes hydrolysis, and the enzyme maltase belongs to the class hydrolase reaction. Another one is the Lyases, catalyzed addition of 2 groups to a double bond, or the removal of 2 groups from adjacent atoms to create a double bond. So this one, makita nimo that there is an addition, there is the addition of two groups to a double bond like this one. No? So naka double bond here, there is an alkene here, and H2O, H2O. Water is being added here, HOH. So mura rin siya, if you remember your alkene reaction, mura rin siya addition reaction, like in the usual reaction of alkene with water, usually add sulfuric acid as our catalyst. But in this case, for biological system, we actually have Lyases. And this one, our substrate is fumarate. We call this particular enzyme for this kind of reaction as a fumarase. But you notice that HOH is added here, and the double bond is being broken, and you have two groups being added here. Pag inana in a case, then you call this one as a lysase, no, na formation of new bonds. And there is a removal of two groups of adjacent atoms to create a double bond. So either you create a double bond or you break the double bond to form a new two bonds here. Then that kind of reaction is lyase. Another one is the isomerase. It catalyzes the isomerization for rearrangement of atoms reaction. So for example, here, you don't have any other reactant or reagent. So you notice here you have 3-phosphoglycerate, acetyl bond O, you have yours H2O. This is the phosphate group. So now phosphate group is simply like P double bond OOO. Okay, this is the phosphate group. And this one is being transferred here, and hydrogen is being transferred here. So pareha siya, if you look at on the molecular formula of this, pareha siya, the difference is the connectivity, and the two actually are isomers. Isomers, constitutional isomers, na otro lang ang arrangement of the atom. So in this kind of reaction, this belongs to the class of isomerase. And for this particular enzyme, since our substrate is 3-phosphoglycerate, we call this one as phosphoglyceromutase. Mutase, and there is isomerization. No more siya mutate. Mutate, just changing the connectivity of the group of atoms. So again, call this one as isomerase. The other one is the ligases. Okay, ligases catalyze the joining of two molecules with the help of ATP. Ligase or synthetase. The S on the last part indicates only that there are many of them. No? So catalyze the joining of two molecules with the help of ATPs. Notice here there's an ATP, and there's a joining of two molecules. One is CO2 and the other is this one. They are formed all together, okay, forming a bond here, H2, and then you have your COO here, and ATP, nasa ATP, and you form a bond between two molecules. So this kind of reaction again is ligase or synthase, synthesized into one. And ADP is just part of the process. The ATP, the adenosine triphosphate, mahimo siyang adenosine diphosphate, no? So duha na lang ka phosphate group that can be seen. Plus the phosphate is being released as a free phosphate in the solution, in the wherever the reaction occurs for this particular reaction. Okay, so in summary, we have the main class. You have the oxidoreductase, transferase, hydrolase, isomerase, lyase, ligases, no? Ilan na to? Na. 2, 4, 6. Okay, and there are selected substances that usually where this belongs under this class. So they have the oxidase, and there is oxidation of a substrate, reductase, and there's reduction of the substrate, dehydrogenase, when introduction of double bond, oxidation by formal, when there's introduction of double bond by the formal removal of two hydrogen atoms, or when the hydrogen being accepted by a coenzyme. Dehydrogenase belongs to oxidoreductase main class. And then you can also have in the transferase or subclass, you can have the transaminases, transfer of an amino group between substrate. From the word amine, aminases, amine, just add an ase at the last. So transaminase, there is a transfer of amino groups. But since this is an enzyme, we end with ASE, so transaminase. Butangan og additional S kay many. Then you have the kinase, transfer of phosphate group between substrates. So this one belongs to transferase. For hydrolase, you can already, as I've mentioned earlier, you can already know what kind of reaction is being involved. There is hydrogen, water is being involved always. And you can see a bond breaking here when water is being involved in the process. So example is when you try to hydrolyze an ester linkage in lipids. Pag na-ay ester and then butangan na to water, okay, ma-recover na to ang carboxylic acid and an alcohol in the process. But in that case, this involves lipase. Now, this kind of reaction with the hydrolysis of ester linkage, you have the lipase. When we are looking at the bond amide linkage in proteins, for example, and add na to water, H2O, then this one is protease. From the word protein, from the protein. If atong starting material is a lipid, then you have the lipase. Pag atong starting material or atong reactant or substrate is a nucleic acid. For example, if we're trying to hydrolyze a sugar phosphate ester bond in nucleic acid, then we have the nuclease. And then if we have the hydrolysis of glycosidic bond, sa carbohydrates, diba si carbohydrates na atay glycosidic bond, then we have the carbohydrases. And if we have the phosphoester bonds, you will have the phosphatase. Okay, for isomerase, there's also the subclass, the racemases. If you want to convert the D to L isomer or vice versa. If you remember, something yung D, the usual amino acid, no? It's in the you have no, for the glyceraldehyde, you have the D glyceraldehyde always. If you want to convert that to L, you have to use the racemases class. So malahi lang ang iyahang stereochemistry from D to L. Okay. For if you want to transfer functional groups from one position to another in the same molecule lang, no, you have the mutases. So the mutases, katong different more constitutional isomers, yeah, no, where one group is transferred, one function is transferred from one position to another. Pero kung stereochemistry ang imo itong tanawon, like from D to L or say R to S, then you have the racemase enzyme. For Lyases, we have the dehydrotases. On the word dehydrate, no, we want to remove water from here. So the removal of water from the substance, and that is Lyases. Decarboxylase, we want to remove CO2 from the substrate, from the word carboxy, no, carboxyl group, you have the CO2 removal, you have the carboxylase. You want to remove the amino group, ammonia, you have the deaminase. If you want the addition of water to the substrate, then you have the hydratase. Okay, this one is different. The hydratase, lahi ni siya ani hydrolysis, no? Sa hydrolysis reaction man good, ma-break ni siya, ma-break ang imuhang bond. In this case, you add water to the substance. For example, na kay double bond, no? You have the Lyases there. Okay. For Ligases, you have synthetase, the formation of new bond between two substrate with the participation of ATP. So again, you form a new bond between two substrate. Mura kaga synthesize, no, kay from two himong isa. And you have the synthase synthase. Mura ka synthesize og duha ka substance into one na lang, you have the synthase. And synthetases, pagdaghan. Synthetase, pag isa lang. Synthetases, pagdaghan. Okay, and if you want to form a new bond between substrate and CO2, again, with the participation of ATP, you have the carboxylase. Carboxylases, pagdaghan. Okay, so you form a new bond, but the appeal mo si carbon dioxide. So formation of new bond, you have that synthetic carboxylase. And again, this two belongs to the group, to the main class ligase. So you form a new bond in this case. So you notice that for this kind of reaction, you notice that usually in biological system, they involve ATP or adenosine triphosphate. Okay, so there are 6 major classification of enzymes. Match the name of an enzyme to its correct function. Okay, match the name. Number 1, hydrolysis of maltose. What do you think? Anyone?
Maltase, ma'am.
Yes, very good. Removal of hydrogen from lactate ion. Na may idea, no? From the name itself, ang imuhang na may
Hydrogens, ma'am.
ha?
Lactate
Lactate.
hydrogens.
Okay, very good. Anyone? Oxidation of fructose. Fructose oxidase. Very good. Rearrangement or isomerization of malate ion. Isomerization. Na may idea from the name.
Malate isomerase.
Is malate isomerase. Yung pangalan siya isomerase kay ka-transfer lang na siya og ions, no? Na siya constitutional isomers nga tong na himo there. And then catalysis of hydrolysis, it catalyzes rather the hydrolysis of cellulose. Remember, in cellulose there is a glycosidic bond there, right? For example, ini glycosidic bond sa yung cellulose, for example, yung flour ninyo, no? Or sa flour inyong source niya, inyo siyang gamitin ninyo siya kaya mo a simple sugar, no? From the very big carbohydrates nga atong gi-take, for example, unsang carbohydrates ang very big nga atong gi-take. Let's say flour, di ba? It's a source of carbohydrates. A source of carbohydrates kanang mga dapa. Namukaon mo og diba dagan klase nga flour, any source of carbohydrates, no? It's a very large carbohydrate molecule. And pag i-digest na siya sa kuan, let's say mga gulay, no? Sa gulay, it's made up of daghan nga cellulose, no? If you want to digest ka ng mga cellulose there into simple one, kasi gamitin nga enzyme, you have anyone?
Cellulase.
Cellulase. Okay, klaro kayo. It's very simple to identify the correct name for the enzymes being involved in a particular reaction. So what enzyme class do the enzymes that catalyze the following reaction belongs? I think nahatag na ni siya ganina. Si COH, nahimo siyang zero bond O. Kina-oxidize siya, no? So it belongs to the oxidoreductase class. Tanawa lang to ninyo, balikan lang to yung unang ka-class later, no? Kung di pa ninyo siya mag-class. So here, this kind of reaction, balik ka reaction, COH, zero bond O. To what main enzyme class do the enzyme that catalyze the following chemical reaction belong? Here you can see this is an amino acid, no? Antayan ninyo, you have C, double bond O, you have CH here, this is the alpha carbon, you have the amino group, and the COOH ni siya supposedly, but it binds with another amino group, forms an amide bond here, and there is water being added here. Pag add ni water din here, this is kind of a hydrolysis reaction. So what happens? Si OH, ano din here? The hydrogen na adere. Okay? And COH, of course, in water, supposedly you have C double bond OH, but since mag-dissociate siya, it becomes C double bond OO minus. So, si NH2, nahimo siyang in water, nahimo siyang NH2 plus, NH3 plus, because it's an amine. Okay. So, in this process, what happened? Ni hydrolyze. So, si hydrolysis reaction, asa na siya? Asa na siya nga class? Tugyo na to. Mana siya sa hydrolase. Okay, ang atong particular enzyme that could catalyze that kind of reaction is protease, the hydrolysis of amide linkage, naka sa hydrolase. So since this is an hydrolysis reaction, this one is the enzyme that would be involved in the main class of enzymes, the hydrolase kind of enzyme. So balik-balik, no? So kung ano lang ninyo, exercise ninyo, you would know what kind of enzyme. And certainly, magawas na siya in any reaction, in any question for the exam. So for the enzyme action, there's actually different models that would be involved. And there's what we call as an enzyme active site. It's an enzyme active site. So if you look at on the structure of the enzyme, there is an enzyme active site. This site is a relatively small part of an enzyme, of the enzyme structure involved in the catalysis. So for example here, mo niya itong enzyme, no, na ay particular surface niya, sa yung structure no, nga ma-involve sa catalysis. Okay, this active site, for example here, this is what you call as an active site. This is the one where mo fit siya or mo detect siya sa a particular substrate